Welcome back, guys, and welcome to a more of a kind of like an office kind of feeling. That's crap. Let's do that again. Hi, guys, welcome back, and welcome to the breakdown of the stock map on the Altea, so we can start tuning this bad boy up. Let's go. Right, hello there, guys. So here it is, and time to start looking at the map because obviously we ran the car on the dyno, and we kind of know where it is. We read the car with CMD. We've took some logs. We're ready to go. This is the stage now where you take what you've got and you start pulling it apart to be able to tune the car. So get used to looking at this map because we're going to see it quite a lot. So here's the Altea. It's going to load it into WinOLS as a, what is there? I'll go fresh as a new project. So this will start the project base of everything we're going to do from now on. So this will always be the stock file of everything we're going to be doing. Just turned on some. What am I turning on here? Let's do it like this. 16U1. See out there. That's what it is. Away we go. So once you first open up the map, you're not going to be met with a lot because WinOLS isn't that, it's not really going to give you anything that you can start tuning from. This is kind of like the start of all tunes. So when you put your car in for a dyno or anything else, and they first read your car, this is what they're met with. Now, we could sit here all day and build out all the basic maps, but which, it's not hard. I suppose it's not hard to do. We could build a few just to get you going. But nowadays, we've got other things available to us to speed up the process. So, like I know these are driver's wish tables based on gear. You've got flick through, pressing spacebar, just flicking through. You've got torque table there. So that's a torque request table. So that's another torque request. It's just probably the second one. Then we've got these like smoke limiters that want to be by math, that want to be by map. At the minute, we're still by math. I'm probably going to switch to map because I've got that broken pipe. Or do I just change the turbo and then go from there? Who knows? You've got Lambda tables. You've got the Newton meter torque request table. Kind of like switches from fuel to torque. You've got soy tables. So soy is like your start of injection. So that's going to be when the injectors first start to start fueling the engine. And then you've got how long, which is the duration. So that's these tables here. So these are the duration tables. So you've got when did it start, how long do they put it up for to give us the amount of fuel that we kind of want. So all those tables have got maths attached to them. So then we've got, that's like a turbo wastegate table. So the wastegate is the VNT. It's what the ECU uses to open and close to control the boost. So that's that. And we've got a boost table. So this is the boost request table. So you can target a specific boost, which the ECU will use the map sensor to control using that VNT. You've got a boost limit table here. There's a single byte for your boost maximum. Then there's other tables. Inverse driver's wish. You've got the hot start, cold start tables. And that's pretty, you've got other bits here, like you've got at the end here, there's diag limits, which we will need to look at when we start looking at bigger boosts and things like that. So when we start setting this up for more power, obviously we'll stage one tune it at first just to kind of get everyone used to what software and the logger we're going to use. Because I'm not going to use VCDS from now on, I'll switch to my own logger. But VCDS is good enough and everyone's got it to kind of like do the same thing. And when you're logging them, everything's got limits in there. So like your boost has got a 1.6 bar cap, which we're going to be wanting more of. There's a milligram of fuel limit in there too. And we want to change these to be able to see. It's one thing changing a map sensor. So I think this one runs a 1.6 bar map sensor. We'll have to look. We'll look at that. But that'll read up to 1.6 bar, which is fine. We could put a 3 bar on. But you still won't see any more than 1.6 bar because there's diagnostic limits attached to it as well. So we're going to have to change those too. So we've got our work cut out, we've got some work to do here. So first thing I'm going to do is speed up our little process just so we can start looking into it. And this isn't a massive video just of me building out the map pack. What I'm going to do is I'm going to use the StageX. So find solutions, power division, which is its Magic Motorsports StageX kind of department for doing this map side. And what I'm going to see if they've got, which they have, I could buy a locked quality map pack from them for 22 credits, but it works out to about €22. I could also do fault codes in there for free, part of their beta program at the minute. So I'm going to buy that now because I'm on the, I think I'm on the Plus package. This is actually half price. That would normally be €44. Now they have just upped it up to 22 from 20, which kind of annoys me a little bit because you buy the actual credits and packs of solid numbers and then end up having to break into that with this. So where I used to get 5 maps for €100, I can now get 4 and have annoyingly like 12 credits left over. So it kind of just gets a little bit annoying. And of course, then if you buy another 100, you're gonna have 24 credits, you have 2 left. It's just you're always gonna end up with some left over. So it's just a bit of a crap way of doing it, but that's where we're at. So double click that. Do you want to build it? Buy. So I've got credits, and that now, yeah. So this now has put a lot of this into kind of map form for us. So now I've got the driver's wish tables. The only thing is it doesn't tell you what the driver's wish tables are. Now these are actually geared, and you have a reverse gear too. So you'll have got 1, 2, 3, 4, 5, 6 maybe, and then a reverse. So it could be a 4-wheel drive, whatever. So we normally keep them in line, but you can use these for all sorts of stuff. So what these basically are is everything the ECU does uses a sensor on the actual car. So this will be the throttle position. So that's a requested throttle position from the driver. So it's where it all starts. To you being the driver, that's your requested where you want to pedal. And then you've obviously got your RPM. So say this is a table. And then in the middle, we call this a Z-axis, you've got your request. So at 100% throttle, 4,000 RPM, you've got 300 Newton meters request. So we start looking at the logs to try and, can't remember if I'm sure I did look at torque request. So if we go to, I used Rostec, so if we go to Rostec, here, VCDS, logs, probably the last one I did, yeah, Altea. So we just start run log 1 or log 3, but log 3 because I changed it in there. So we'll look at log 3, and we'll look at the RPM. So this is like the development stage of what we would normally do. So injection quantity, so we're looking for around about 45 milligrams of fuel. Injection duration, so that's that duration that I spoke about. So it's 23.5-ish, maximum 24. We've got injection start, that's the start of the injection, so 23. So that's just after top dead center, because if we go by the maximum, say if I went 23.6 at the same point as here, when we're looking at current 21.9, so 23.6, that puts us at what, 2 degrees after top dead center. So that would be your end of injection. So that's how it works. So, right. And then we've got intake air temp, coolant temp, smoke limitation. So we'll look at this. So we're at 334 Newton meters of smoke limitation. Mass airflow, that's what your math's reading. So you can calculate airflow. Boost pressure, obviously we had that bit of a dip. We'll look at that. So a bar. So maximum, I can't ignore the peaks because that's just where it comes in a bit hard on the dyno. I'm kind of looking for the requests and the actual. So we're asking for a bar, and we're seeing just over a bar, and it kind of like wobbles around a bit. Charge pressure control and engine torque. This is the one I'm looking for. So engine torque here is 273.3. So we'll be looking for that. So already we're nowhere near these kind of limits. Because what the ECU is going to do is it's going to be looking for the minimum request. So if I've got 3 tables that are laid out, I've got driver's wish, I've got torque, and I've got smoke. It'll be looking at those 3, taking the lowest, and that's what's going to become the actual request. So as part of mapping, this is what you kind of got to understand. It's not just I've got to change this and I'll get that. It's what else goes into it to kind of like stop it. So we've got a few tables that give us here, desired air quantity. A lot of them are just going to be math tables. So we've got EGR. So this is hysteresis, so basically how long it's going to be open, how much of that EGR it's going to use at certain points of the RPM. Keep going. You're going to have a few single bytes lying around, like that's EGT sensor. And you've got friction torque limiter. So remember that 273? It's kind of looking at this table. So we're looking at, let's get that back open. Where's that gone? Open recent log files, go to that one. So we're looking at 273-ish. So it was coming in at 275. And the log started at, say 2000 RPM. So 2000 RPM, 278. 275, so it's kind of like floating across this line here, because on this axis you've got atmospheric pressure, so that is the pressure in the air around you all the time. You've got your RPM point, and in the middle it's got a limit of torque. So like I said, just because those tables down here were saying 300 odd newton meters, you can see that, yeah, there the request is there. You know, there's lots of requests there, but we're nowhere near that. And this will be the limit table. So when you're tuning these cars, sometimes it's just, you know, I'll show you, but sometimes you can just find your lowest table, raise your lowest table to your highest table, and you'll make power just like that. It's like free power, if you like. You know, the rest of the table is going to be scaled correctly, should be, and then it's just a case of finding out what's what. So we're already in. So we're running a bar boost, 275 newton meters torque request. So this is your AFR, it's your smoke limitation by Lambda. And then you've got your smoke limitation by map. So that's your map sensor. So if you switch to map sensor, you're going to be running this. It's like a, how can I say, it's like a request table limited by the airflow. And we're running a bar, so 200 millibar, which will be a bar, actual bar atmospheric. There's always air pressure inside all the intake parts. We're adding to it using a turbocharger. So you'd be running about a bar. So this is kind of where it was. So we would be running down this line here if we were obviously logging what we want. And then you've got smoke limitation by Lambda, even though this one here is math. And it's got Lambda and it says milligrams of fuel. I think I've actually got this wrong, you know. Smoke limitation by Lambda, but yet you would never be targeting a 5.17. So I think they've kind of got this wrong. I would say that this would be 0.1 milligrams of fuel by math, not Lambda. So they've actually got that wrong. So I'm going to change that. We'll test it, but you can't take everything as gospel. So smoke limitation by math. Because this looks like math airflow, air mass flow, yep. And in the middle would be milligrams of fuel, not Lambda. You wouldn't target that by Lambda. There's actually Lambda maps for that. So that was a bit confusing, but we know what the score is. So this is by milligrams of fuel, and this one's by milligrams of fuel. Now you'll only run one of these depending on where your math to map switch is. So if we switch to map fueling, this would get ignored and this would be used. Currently we would be on math fueling, so this would get ignored and this would get used. So just because you've got the tables doesn't mean the ECU is going to use them. It can easily just bypass tables. There'll be lots of functions and tables in here that aren't even switched on. So it's a case of finding out what's what, how the car is actually fueling, things like that. And a lot of that is just by pretty much data logging it and see where you see it. So that's your smoke maps. So that's another fuel request. That's like your third in the line. So you got your driver's wish, torque, smoke. They're your three for your fuel. And these are kind of reference tables. These are your Lambda tables. So that's what I'd expect from Lambda. So you've got 1.3, 1.4, 1.2, 1.07. Math there, RPM there. That's Lambda in the middle. I'm not sure they're even used on the EC16, but we'll find out. Then you've got your torque conversion tables. So what this basically does is looks at your fuel that you're currently at and then chucks out a torque figure based on that. So you can fudge around with this, especially if you've got DSG cars and things like that, to kind of make the car think that it's outputting lower torque than it actually is and things like that. So you'll have all your tables for whatever you want to do, and then you can revert that back to torque, which is what the ECU is going to target at the end of it. Then we've got gear torque limiters. These cars don't really use these, so they're always maxed out. You can use them for other things, as I've done in the past, like launch control and things like that. Then you've got start of injection. So this is, as I said earlier, this is the start of injection. So it's the point that the injectors will start to open based on the fuel. So these are very tight calculated tables, because you've basically got your ECU request at the top. So you're targeting 45 milligrams. Then the ECU will look at that and it'll say, right, 2,250 RPM at 45 milligrams. I need to be opening the injectors at 14 degrees before top dead center. So these are before top dead center tables. So BTDC, table. So don't take these as 14 degrees. It's actually 14 degrees before the top dead center. So obviously the wider the faster the car's going, the longer you need to be opening the injectors for to make the same kind of fuel in, because you've got less time. Obviously more RPM leaves less time for the ECU to be able to do what it needs to do. And then you've also got at the end of the table, obviously the manufacturer kind of wants you to change gear, so they're really going to like shut the fuel in a little bit up that kind of point, which you probably wouldn't even really feel, and it'll like slow the car down, so you're changing gear. They always kind of want to keep you in the middle. Obviously that's the torque band, that's your power band, that's kind of where you want to be anyway. So these would be also temperature based, and then you'd have a limiter here, one overall. Again, we'll look into it, see what's what with that. Then we've got start of injection limiter. So this is how much the injectors can actually be open for. So say if you targeted, say 29 here, you'd only see 28 because there's a limit against that number. So with every request, there's always a limit, and we can move those limits, but that's kind of where we kind of find ourselves and what we kind of got to do the different things that we need to do. So when we come to changing the injectors for the PD130 injectors, we're going to have to do some work here, and there's a couple other maps just outside of here, like axes and things, that we're also going to have to touch on. So, and also here too. So we'll get to them. Obviously this is just a map pack that they give you. We're going to add to this quite a lot. Then we've got the duration tables. So we've got the start injection, and this is how long you're going to hold that injector open for. So if you start the injection at 14 degrees before top dead center, this is going to say right now hold that open for 16 degrees. So start at 14, hold it open for 16, which should give you probably about 2 degrees after top dead center, which is the end of injection, and that should give you 30 milligrams of fuel. Pretty much how that works. So again, we're going to go into that. We're going to set these up. So as we request more fuel, like we say, we're going to 70s, we're going to have to move this axis, and we're going to have to do all this maths that the manufacturer's done to extend it. So we'll do that. We'll show you that. We'll have to change this around and do all sorts of stuff, but we're going to get into that. What else we got? Idle correction, ambient pressure. So if you've got big cams and it's got a rough idle, we're going to come to that. So these are your turbo control tables. So when people are doing like the deep idle and things like that, you're messing around in these tables. What they basically do is point the ECU in the direction of what it should be doing. So they run on a PID system. So being a PID system, there's adders and takeaways. So you have a target. So say you want to run, you're at 40 milligrams and you want to run the duty open at whatever, say it's going to target 64.3 on that VNT, which is about, I can't remember if these are backwards or the other way around. I guess it'd be 97%, that'd be closed. And then 40 would be 40% open to kind of like balance that boost out. So of course you want the spool up down low and you want it to be controlled in the middle. So these used to be back to front, but obviously this one isn't. And what that basically does, it gives you a targeted boost. So say if you're targeting a bar like we was earlier, it's going to try and keep you on that line. And this should be as close as possible to do that without leaving the PID system to really step in and intervene. Because what's going to happen is if you get an overshoot of boost, like we did on spool up on that boost log, let's get that boost log up. Kind of make a bit more sense to it. So if we look at that boost log down here, so this charge pressure controller here is trying to keep that boost open and shut by itself. It's not necessarily targeting, it's not necessarily running across one of these. We kind of want it to. We find them that we're running quite far out on here. That's when we make the adjustments to keep the control a lot better, a lot faster, and a lot more consistent. Because if we're running out of these all the time, then the car's having to react to something. So you've got the PID. So you've got the proportional, which is the P, which is kind of the ramp. So it's going to get your turbo going. It's got, you can have an adder against there as well to get that tool, that spool going. You've got I, which is kind of like the control, and then you've got the D, which is the stop. So if you can picture it in your head, your P's, you're kind of pushing the car. Your I's are continually pushing the car, and your D is trying to get that car to stop on the line. So that's pretty much how that works. If you step into a D of the PID control, then you're kind of in shit streak and it's kind of miles out. So you kind of don't want the I to be doing anything, but it probably pretty much always will. And then you don't want the D to ever step in, because that's probably when you're going to drop into limp mode for whatever reason, under boost, over boost, whatever. You've got your boost request. So again, there's your boost request. And you've got your boost limit based on atmospheric pressure. So as you can see, it's going to let you run about 100 bar over. So if you start really going over that, it's going to shut that throttle. It's going to shut the VNT and open the VNT, and you're going to lose all that boost to try and get you back in towards this kind of line. But being a mechanical object, being a turbo is, if you lose too much boost for trying to control it, it takes a long time to build that back up again. So that's why we have PID systems and we get the control right and everything else. And when we start looking at so we slap on a PD 130 turbo or a hybrid or whatever else, probably going to be going hybrid. But if we slap that turbo on, we're going to have work cut out to kind of get the control on that turbo to get it to do what we want it to do. Not just at full throttle, but pretty much everywhere, which is kind of where a lot of road tuning comes in. So we'll be doing a mix of tuning on that setup to get that bang on. Because we want to make it all the way to the Nürburgring or wherever we're going to go, without dropping into limp mode every 5 minutes and getting overtaken. So we can have our work done there. Again, you're going to have more control tables. These use different conditions and things like that. Then here we've got another EGT sensor cylinderization. So that's basically like the 5 volt sensor. This one isn't used. So again, like I said earlier, there's going to be tables which aren't used. So we normally have a value in here. So at 0 volts, it's this, and at 5 volts, it's this. And the ECU can use that as a scale. But it's not used. We have an inverse driver's wish table. And another inverse driver's wish table. Then we have another couple of tables. So that's pretty much it for what they've given us. But there's actually more to it than what we've got here. We're going to have a lot more tables involved in what we've got to do. And there isn't quite enough here to be able to do what we want. So the thing that we wanted to do today is look at the duration based on what fuel we're at, because I kind of know where we want to be. So if I want to be targeting around 70 milligrams of fuel, maybe a little bit more when I run the PD 130 setup. And I want to know if these injectors would be good enough for that. And I see that our target on here is on 50s, which is, it's all right. And our duration tables are, you look at the axis more than the actual. So we're looking at 60. And it's not too bad actually. It's not actually, the start of injection isn't massively long. And then with our duration, so again, we're scaled up to 60 milligrams, only 70, but we're already running quite a high, like 27 is quite a high duration wise. But we'll have to see how far these injectors go. What I wanted to do is do it bit by bit instead of just chucking it all on. So we'll stage one it, then we'll chuck a turbo on. We'll see how far they can go with the injectors, change with the intake, all that kind of stuff, just to see where we are. We're not crazy off. I mean, I reckon I could probably get a PD 130 turbo going on these injectors if they can actually fuel that much, because I know on the logs then we was only running about 270, which was about 45 milligrams. We've seen about 100, was it 110 brake, something like that. So I want to be, as a stage 1, I kind of don't want to be touching this table. I just want to work us up to the point where we can target around 336. That's going to give us that amount of fuel, and then see if the car can do it, what we're going to make from the car and things like that. And then we'll step on to the next level. So I can see one of the tables it hasn't give us is the map sensor table. We've got the boost, atmospheric pressure and all that kind of stuff, but we don't know what map sensors on this car, and I was quite interested to see. I think it's going to be a 1.6 bar one. So what I'm going to do is going to switch to search. I turned the file earlier. To 600, I think. Yeah, it's found one. And yeah. So we've got this is the map sensor scaling. So it's going to press K, make that into a map. So it's a 2 by 1 map. So we've got 2 there, 2 axis, 2 for the map data. I'll just press K on that, and I'm going to save that as map sensor scaling. Leave it as it is, I think. Yeah, leave it as it is. So there's our map sensor. So I'm going to need a bigger map sensor, I think, because, well, the PD130s, they run about 1.55 bar-ish, flat out. But I'm going to want to go hybrid. So I could probably get away with that with just a PD130 turbo, just about. I'll be on the boundary. Or I could switch it up to a 3 bar and just give myself that little extra room. Because I know the PD130s have got 3 bars on them in stock. Or we can jump straight to a 4 bar and just be done with the map sensor up until the point where we're running just over 2 bar. So, I mean, 2 600 meters I've got about, because I'm in the UK, we get about 1,000 on the atmospheric pressure. So that'll be just off that. And then you've got the 1.6 on top, which is positive pressure, which is what we're going to add with a turbo. And then you've got the voltage, which is the scaling. So that's the map sensor. So fueling, I think we'll be okay, maybe, with a 130 turbo on. Map sensor, I'm probably going to change, so we'll get one of those ordered. I think that would be it for this session. So that's kind of like the map start. The next thing we'll do is get the car in a dyno and then push it on what we've got before we start changing parts. I've already started ordering parts. Well, I'll add that into the next video. We'll probably end up with doing a session on dyno, a session building the car up, a session doing this kind of stuff, just to kind of like, so I want everyone to have the full pictures with doing it all. I'm also going to have to put all these diag limits into some sort of sense, because I'm going to hit these quite fast, I think. So 1.6 bar, I could do that pretty much on the stock to stage 1. I'm probably not going to be seeing 1.6 bar on that turbo, but once I change the PD130 turbo on, I'm going to be doing that. So I want to be changing the diag limits, and also the fueling. I don't want that 70 milligram cap. We want to be doing like for about 90 by the time we're finished, depending on what turbo we'll go for. So we've got our work cut out, and we've got some fun stuff to do. So this is tuning. This is what it's about vlogging, understanding the setup, and then that's when we start putting things into stages and things like that. But I'll explain that as we're going through. So thanks, guys. I hope you enjoyed that video. Hope you kind of like starting to piece together what we're trying to do here. If not, keep going. You'll get it. I'll be as open as I can with what we're doing, and anything in the comments that you might want to know or anything else. Obviously, don't go too far ahead of yourselves. Some people like to do that in this game. We are just putting this together as a fresh. So we've just opened it up. We're just having a look. This is what we're going to do. So please like and subscribe, because it really helps the algorithm and all that kind of stuff. But apart from that, thanks, guys, and I hope you enjoyed it so far.